Correlation. It is the mutual relationship between two or more things. It is a statistical measure of how one variable fluctuates with another. Now here we do a particular problem of correlation. We see that there are 12 learners A, B, C, D, E, F, G, H, I, J, K, L. Now over here we see that these 12 learners had given two tests. The first test, they got the following numbers: 50, 54, 56, 59, 60, 62, 61, reaching up to 74. That's the second column. Now we move to the third column. We have the marks for the following students, and this time for the second test, which is 22, 25, 34, 28, 26, and still 40. Now, one of the area that we have to remember, correlation will actually determine how much is the first test relevant to the performance of the second test. So in order to calculate that, we have to take a symbol which we call as Rx for the first test, and we take the test Ry for the second test. Now we have to find out what is actually Rx and Ry. So now let us move on. The first test, we see we have to put the value of Rx now on the column where Rx is written. Now we see that the highest mark is 74, right? So student L received 74, which is the highest mark. So he is the one who is first in the class, right? So we will give that as 1 in the Rx. Actually, Rx will determine the merit position for each of the students given over here, taking their marks into consideration. Now, as we see 71, so student K and J, both of them obtained 71. Now there is a little bit of a problem. Whom we should be giving out the second position and whom we should be giving out the third position. So in order to clear that, we have to understand if there is a tie like this between two people, so they will get the midpoint of the tie, which means 71 and 71. They are taking out the second and the third position. As a result, what we will do, we will give them the midpoint of that position, which is 2 the second position, 3 the third position. So 2 plus 3 divided by 2, which ends up getting 2.5. Similarly, we put 2.5 for both of the learners because their numbers are same, so they cannot have different merit positions. Now as the second and third positions are taken, the next position would be the one who is fourth in the class, and we see 67 obtained the fourth position. Then the fifth boy in the class would be, comparing the first test, would be getting 65. So similarly, we find out all the merit position of the first test like this. Similarly, we do the same for the second test as well. But this time there are too many people getting the same mark. So it might be a little difficult to calculate, but we have to bear in mind that we have to do with a very relaxed mind this area when we do the merit position. So when we do it, we see over here that the highest mark was obtained by the one who got 40, and then the second highest was 36. But as we go to find out the third merit position, we see 34 is obtained by two students, by the student J and the student C. So what to do? Again the same, they are taking the third position and the fourth position, right? Because there are two people, and because they got the same mark, you cannot actually give them, one third and another fourth, because it will be a very much an injustice. So in order to do that, we again find the midpoint of the third and fourth position, which is 3.5, and give both of them 3.5. So 3 and 4 is now covered by the midpoint of 3.5. Similarly, we go and give the fifth position to the one who has obtained 32, because that is the fifth position. Similarly, we carry on this calculation of Ry. for the entire column. Now D is equals Rx minus Ry, so we just subtract Rx minus Ry and obtain the value of D, and D multiplied by D means D square, so we just square the value we obtained for D. So in this way we actually find out Rx Ry and get the value of D square, because the formula of correlation will be requiring the value of D square. So we saw that the learner was 12 because there were 12 learners, and the value of D square is 74.5, which is obtained by summing all the values of D square by adding them up in the last column. Then we put the formula for correlation: 1 minus bracket 6D square n bracket n square minus 1. So just putting in the value over here, we get the value as 0.74. Now 0.74 is a very high and substantial value, showing that the first test have a strong relationship with the second test. Thank you all for listening. I believe you have understood how to calculate correlation and what is correlation all about. Thanks.